Hello. In this example, we want to find a polynomial function of least degree having only real coefficients and zeros of 3 and 2 plus I. Now, there are a couple of things here. First of all, we want the least degree possible, but also we want real coefficients. And we're told the zeros are 3 and 2 plus I. But remember that the only way to have 2 plus I as a 0 is to also have 2 minus I as a 0. And that comes from the quadratic function, the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. The only way to get an imaginary number, or a non-real complex number like this, is to have b squared minus 4ac being less than 0. And because of that, you're always going to get complex conjugates. So that means that if you have 2 plus I as a 0, that means that 2 minus I must also be a 0. Now, think of it this way. If 2 plus I and 2 minus I are zeros, that means that the function somewhere does not cross the x-axis. Now, in this case, 3 is a 0, which means it does cross it in one place. But it's a higher degree polynomial now because we have a couple of non-real complex zeros. Now, that means that our function, f of x, is equal to the 0 of 3 means the factor of x minus 3, and the 0 of 2 plus I means the factor of x minus 2 plus I, and then times x minus the 0 of 2 minus I. Now notice that I can distribute the negative here and distribute the negative here. So this is going to give me x minus 3 times x minus 2 minus I times x minus 2 plus I. Now I'm going to use square brackets here, and notice that this is actually a difference of, well, it's multiplication of two conjugates. And whenever you multiply them, you're going to get a difference of two squares, because a plus b times a minus b is a squared minus b squared. So this is actually going to give me x minus 3 times the x minus 2 squared minus the I squared. Now notice that I squared is negative 1 here. So that's opposite of negative 1 means all of that becomes positive 1. So this is going to give me x minus 3 times, and I'm going to go ahead and FOIL this out, or distribute this out, making this x squared minus 4x plus 4, and then this minus I squared is positive 1. And then 4 plus 1 is 5. And so this is going to give me x minus 3 times x squared minus 4x plus 5. Now, some of you may be wondering if you can factor x squared minus 4x plus 5. You cannot. And you can see that if you just try and factor it out. But also, the reason that I know that, even without doing anything else, is because I figured out this quadratic from the 2 plus I and the 2 minus I. If you have two non-real complex numbers that are conjugates, and you multiply them together, or the zeros, and you multiply everything out, you're always going to come up with a quadratic, and that quadratic is guaranteed not to be able to be factored. So the factorization here, not the factorization, the function here is f of x equals x minus 3 times x squared minus 4x plus 5. Now notice that this is a degree 1 times a degree 2. When you multiply those out, you're going to get a degree 3. And this makes sense because I had 3 zeros here. A 3, 2 plus I, and 2 minus I. Also notice that I didn't worry about any leading coefficients because it just says find a polynomial function. It doesn't say to find a specific polynomial function. Technically, I could use any coefficient out front. So really, this is just asking for some family of functions, but it's pretty much just always easiest to put a 1 out front. Alrighty. Well, have fun. I'll see you next time.